Now let's talk about solids of revolution. For example, if we have a function with graph, for example, let's say y equals f of x. If we rotate this graph about the x-axis, it will just be a reflection in this form. So we have rotated this above the x-axis to this form. So this is just a reflection about the x-axis. So if we reflect this about the x-axis, it is going to look like this. After the reflection, this graph looks like a cylinder. So therefore, if we rotate graphs about either the x or the y axis, we begin to get solid figures. So this graph, when it is rotated about the x axis, it looks like a cylinder. For this one too, if we rotate it about the y axis, you see that the reflection about the y axis begins to look like this solid. If y is given as a function of x, the volume of the solid generated by rotating the part of the curve x equals to a and x equal to b about the x-axis is given us. So in this case, this is given us v is equal to the integral of a to b pi of y squared dx. So we just need to integrate y squared multiplied by I about x. But in the instance where it is rotated about the y-axis, as we've done in this case, then the volume of the solid generated is integral of a to b. Sorry, in this case, it is from m to n, because y is equal to m is the lower limit, and then y equals n is the upper limit. So in this case, it is m to n. So let me cancel it and write it again. So the volume of the solid generated is integral of m to n of pi x squared dy. So the only thing we did is to replace the y squared with x squared and also change the limit from a to b to m to n. The area between the curve y equals 1 over x, the y-axis, and the lines y equals 1 and y equals 2 is rotated about the y-axis. Find the volume of the solid generated. So now, we know that the volume of solid generated, v, since it is rotated about the y-axis, then the volume of the solid generated is given as integral of, the limits were from 1 to 2, so 1 to 2 of pi, then x squared dy. This function was given in terms of y. The function was y equals 1 over x. So what we need to do here is to make x the subject. So you see that by bringing x here and bringing y here, x is equal to 1 over y. And therefore we are going to then integrate 1 over y. And therefore we are going to insert 1 over y into this function. So the volume of the solid generated is equal to integral of 1 to 2 of x squared, and we know that x is 1 over y. So x squared becomes 1 over y squared, then dy. But there is a very important element I've not added yet, and that is pi. So let me put pi here. Since pi is a constant, I can bring it out of the integration, and therefore v, the volume of the solid generated, equals pi. Because pi is a constant, I'm pulling it out of the integral. 1 to 2 of 1 over y all squared is 1 squared is 1 divided by y squared dy. So the volume of the solid generated, y is equal to integral of 1 to 2. I want to write 1 over y squared as y exponent minus 2 dy. So let's go ahead and then do this integration. So you add 1 to minus 2, so it becomes y exponent minus 1 divided by minus 1. Then all of this is integrated at 1 and then 2. However, there is pi here and there is also pi here. So the volume of the solid generated is pi times. Now divided by minus 1 becomes minus y exponent minus 1, evaluated at 1 and 2. I can still write this as the volume generated equals pi into brackets. So let me pull the minus out of the integration so that this becomes minus pi into brackets 1 divided by y, evaluated at 1 and 2. So the volume of the solid generated becomes minus pi. Then now let's put the limit. So this becomes 1 over 2 minus 1 over 1. So 1 over 2 minus 1 over 1 is the same as 1 over 2 minus 1. 1 over 2 minus 1 minus 1 is minus 1 over 2. And then this is equal to minus pi times minus 1 over 2 is pi over 2. And this is cubic unit. The curve y equals x squared minus 2x is rotated about the x-axis. Find in terms of pi the volume generated by the curve and the ordinates at x equals 2 and x equals 4. So the limits are x equals 2 and x equals 4. But we know that the volume of the solid generated, since it is about the x-axis, then it's equal to integral of the lower limit is 2 to 4 of pi y squared dx. So the volume of the solid generator is equal to integral of 2 to 4 pi, then y is x squared minus 2x all squared dx. So the volume V is equal to, now let's expand this, but I want to pull the pi out of the integral since it's a constant. So this is pi integral of 2 to 4, then x squared exponent 2 becomes x exponent 4, then 2 times x squared times 2x becomes minus times minus 2x becomes minus 4x, then exponent 2 plus exponent 1 is exponent 3, then plus 2x all exponent 2 is become 4x exponent 2 dx. So let's go ahead and do the integral. This is pi. So we add 1 to 4 and divide by the result. It becomes 1 over 5 x exponent 5. Then minus 4 divided by 4 x exponent 4, because we added 1 to x exponent 3. Then plus, if you add 1 to 2, it becomes 3. So 4 divided by 3 x exponent 3. All of this is evaluated at 2 and 4. So the volume is equal to pi times 1 over 5 x exponent 5 minus x. 4 over 4 is 1, so this will cancel out. So it becomes x exponent 4 plus 4 over 3 x exponent 3, evaluated at 2 and 4. So the volume of the solid generated pi, V is equal to pi. So this becomes 1 over 5 4 exponent 5 minus 4 exponent 4, then plus 4 over 3 times 4 exponent 3, then minus pi again, because pi is multiplying all of this. Then we'll substitute the lower limit. It becomes 1 over 5 times 2 exponent 5 minus 2 exponent 4, then plus 4 over 3 times 2 exponent 3. So V is equal to, here is 4 exponent 3. Let me make the corrections. So this is 4 exponent 3. So you see that, okay, let me continue. So this is pi times 1 over 5, 4 exponent 5 minus 4 exponent 4. And this 4 can multiply this 4, so that we'll get plus 4 exponent 4 divided by 3 minus pi times 1 over 5 times 2 exponent 5, then minus 2 exponent 4, then plus, this 4 can also be written as 2 exponent 2. So 2 exponent 2 times 2 exponent 3 becomes 2 exponent 5 divided by 3. So let's see if we can factorize some terms out. So this becomes pi. However, you see that this is 4 exponent 5, 4 exponent 4, and 4 exponent 4. So we can factorize 4 exponent 4 out of the expression. So this becomes 4 exponent 4 pi. So let me do this, times pi, then into bracket 1 over 5. But we factorize 4 exponent 4, so it will be left with 4 exponent 1 here. So this becomes 4 over 5 minus 1, because we factorize 4 exponent 4, then plus 1 over 3, then minus, we can also factorize, sorry, this was 2 exponent 4. So we can factorize 2 exponent 4 out of this expression. So this becomes minus 2 exponent 4 times pi into bracket. This becomes 2 exponent 4 times 2 is 2 exponent 5. So this becomes 2 over 5 minus 1, then plus, if we factorize 2 exponent 4 out of here, it becomes 2 divided by 3. So let's solve what is in the bracket. Let's find the LCM here. The LCM of this is 5 and 3 and 1 is 15. So that 15 divided by 5 is 3. 3 times 4 is 12. Minus 15 divided by 1 is 15, times minus 1 becomes minus 15, plus 15 divided by 3 is 5. 5 times 1 is 5. Then this is, all of this is multiplied by 4 exponent 4 pi, then minus all of this. So let's find the LCM here. It's still 15. So that 15 divided by 5 is 3. 3 times 2 is 6. Then minus 15, then plus 15 divided by 3 is 5. 5 times 2 is 10. So all of this 2 is multiplied by 2 exponent 4 pi. So V is equal to, now let's solve this. 12 minus 15 plus 5 is minus 10. 12 minus 10 is 2. So this is 4 exponent 4 pi times 2 over 15, then minus 2 exponent 4 pi. Let's solve this. Minus 15 plus 10 is minus 5. 6 minus 5 is 1. And therefore this is 1 over 15. Now this 4 exponent 4, 4 can also be written as 2 exponent 2. So then becomes is equal to, this is 2 exponent 2 times 4. So this becomes 2 exponent 8 pi times 2 over 15 minus, then 2 exponent 4 pi, then into bracket 1 divided by 15. So we got the volume as 2 exponent 8 pi into bracket 2 over 15 minus 2 exponent 4 pi into bracket 1 over 15. So what we can do is we can factorize 2 exponent 4 pi out. So if we factorize 2 exponent 4 pi, we are left with 2 exponent 4 here times 2 over 15, then minus 2 exponent, we factorize 2 exponent 4 out, so we'll be left with minus 1 over 15. So the volume generated is equal to, if we check this bracket, see that this is 2 exponent 4 times 2 over 15 minus 1 over 15. This term is far greater than 1 over 15, such that even if we subtract 1 over 15, it is not going to cause any significant change here. And therefore, this is approximately 2 exponent 4 times 2 over 15. Then all of that times 2 exponent 4 pi. So the volume is equal to 2 exponent 4 times 2 exponent 4 times 2. 2 exponent 4 times 2 exponent 4 is 2 exponent 8 times 2 is 2 exponent 9. So this is 2 exponent 9 pi divided by 15. Volume equals 2 exponent 9 is 512. So this is 512 pi divided by 15. And the volume generated is approximately 34 pi cubic units. The curve y equals x squared minus 1 is rotated about the x-axis through 360 degrees. Find the volume of the solid generated when the area contained between the curve and the x-axis is rotated about the x-axis by 360 degrees. So the curve is y equals x squared minus 1. And since it is rotated about the x-axis, we need to find the x-intercept. I will know that for the x-intercept, y is equal to 0. And therefore, this implies that x squared minus 1 is equal to 0. So x squared is equal to 1. So if we take roots on both sides, see that this one and this will cancel, so that x is equal to plus or minus 1. So the formula for the volume V, is equal to integral of the lower limit minus 1 to the upper limit 1 of pi y squared dx, because it is rotated about the x-axis. So V is equal to integral of minus 1 to 1. Then the curve is x squared minus 1. So this becomes into bracket x squared minus 1 dx. But there is pi here. So V is equal to, I'm pulling pi out of the integral. Pi integral of minus 1 to 1. There's a squared here. X squared minus 1, because it is y squared dx. So let's expand. V is equal to pi integral of minus 1 to 1 of x squared all squared is x exponent 4 minus 2 times x squared times minus 1 becomes minus 2x squared. The minus 1 exponent 2 is plus 1 dx. So v is equal to, let's do the integral. If you add 1 to 4, you get 5. So it becomes 1 over 5 x exponent 5 minus, if you add 1 to 2, you get 3. So minus 2 over 3 x exponent 3, then plus x. All of that evaluated at minus 1 and 1. So the volume is equal to pi times into bracket 1 over 5 x exponent 5 minus 2 over 3 x exponent 3 plus x, all being evaluated at minus 1 to 1. So v is equal to, let's put in the limit, pi into bracket 1 over 5, then we put in 1 exponent 5 minus 2 over 3, 1 exponent 3 plus 1, then minus pi again. So now we put in minus 1 over 5 minus 1 exponent 5 minus 2 over 3 minus 1 exponent 3, then minus 1. So v is equal to pi into bracket 1 exponent 5 is 1, so this is 1 over 5 minus 1 exponent 3 is also 1, so minus 2 over 3, then plus 1, then minus pi minus 1 exponent 5. Since the power is odd, then it will throw out minus 1. So this becomes minus 1 over 5. Then minus 1 exponent 3, odd power, so it will also throw out minus 1. So minus 1 times 1 times minus 1 is equal to plus 2 over 3. Then here becomes minus 1. So let's go ahead and then simplify this. So v equals pi. We can find the LCM here. The LCM of 5 and 3 is 15. So 15 divided by 5 is 3. So this is times 15 divided by 5 is 3. 3 times 1 is 3. Minus 15 divided by 3 is 5. 5 times minus 2 is minus 10. Then plus 15 divided by 1 is 1. 1 times 1 is also 1. F. 15 divided by 1 is 15. 15 times 1 is 15. Minus pi times. You can also find the LCM here as 15. 15 divided by divided by 5 is 3. 3 times minus 1 is minus 3. And 15 divided by 3 is 5. 5 times 2 is plus 10. Then minus 15. So that v equals pi, then times minus 10 plus 15 is 5. 3 plus 5 is 8. So here's 8 over 15. Then minus pi. 10 minus 15 is minus 5. Minus 5 minus 3 minus 5 is minus 8 over 15. So this becomes v is equal to 8 pi over 15. Then minus becomes plus 8 pi over 15. So the volume is equal to 8 plus 8 is 16. So 16 pi over 15 cubic units. Find the volume in cubic units of the solid generated when the finite region between the curve y equals x minus x squared and the x-axis is rotated through 1 revolution about the x-axis. Leave the answer in terms of pi. So the curve is y equals x minus x squared. So let's find the x-intercept. For the x-intercept, y is equal to 0. So therefore, x minus x squared is equal to 0. So let's factorize x out of this portion. So x, and here becomes 1 minus x equals 0. So the values of x are x equals 0 or x equals 1. And therefore the lower limit is 0 and the upper limit is 1. So we know that the volume generated V is equal to integral from the lower limit to the upper limit, which will be 0 to 1 of pi times y squared dx. So the volume generated V is equal to 0 to 1 of pi, then y squared, it becomes x minus x squared all squared dx. So the volume generated is integral 0 to 1 of pi, and let's expand the bracket. X exponent 2 is x squared minus 2 times x is 2x times x squared becomes minus 2x exponent 3. Then minus x exponent 2 becomes plus x exponent 4 dx. So the volume generated V is equal to integral of 0 to 1 of, let me bring out pi since pi is a constant. Okay, so let me cancel this. The volume generated V, I'm pulling out pi. So let's do the integration. 2 plus 1 is 3, so it becomes 1 over 3x exponent 3. Then 2 plus 3, 3 plus 1 is 4, so this becomes minus 2 over 4 x exponent 4. Then 4 plus 1 is 5, so plus 1 over 5 x exponent 5. All of this is evaluated at 0 and 1. So V is equal to pi, then 1 over 3x exponent 3. And 2 over 3 becomes minus 1 over 2. 2 over 4 becomes minus 1 over 2 x exponent 4 plus 1 over 5 x exponent 5, evaluated at 0 and 1. So let's substitute the limit. So the volume generated is equal to pi. So I'm substituting the limit. 1 over 3 times 1 cube minus 1 over 2 times 1 exponent 4 plus 1 over 5 times 1 exponent 5 minus 1 over 3 0 exponent 3 minus 1 over 2 times 0 exponent 4 plus 1 over 5 times 0 exponent 5. So there is pi here, so minus, let me multiply this one too by pi. So all of this portion becomes 0. So V is equal to pi times 1 cube is 1. 1 times 1 over 3 is 1 over 3 minus 1 exponent 4 is 1 times 1 over 2 is 1 over 2 plus 1 exponent 5 is 1 times 1 over 5 equals 1 over 5. Then minus 0. All of this portion goes to 0. So we can find the LCM here, which is 60. 60 divided by 3 is 20. 20 times 1 is 20. Minus 60 divided by 2 is 30. 30 times 1 is 30. And plus 60 divided by 5 is 12. 12 times 1 is 12. So all of this multiplied by pi. And this is equal to 20 minus 30 is minus 10. Minus 10 plus 12 is 2 over 60. So this is equal to 2 pi over 60. And 2 pi over 60 is equal to pi over 30 cubic units.